Welcome back, everyone. This week, we're going to be talking about the sense that helps us detect a basketball bumping into our head or experience the satisfaction of digging our hand into a bowl of slime. Of course, I'm talking about touch. Now, our ability to feel is very interesting because it is not connected to one part of our body unlike the rest of our other senses. As a result, we need receptors which can help our brain detect touch all around our body. And interestingly, certain parts of our body have more touch receptors than others. Think about it logically. Where do you think we would have the highest number of touch receptors? Well, quite obviously that would be where our touch is the most sensitive. And what do you think would be the reason for why touch may be more sensitive in one area compared to another? Well, quite obviously, because we use that part of our body to touch things more often. So things like our fingertips, our lips, our face, they have more touch receptors because they more frequently feel things. We use our hands in order to feel things, therefore our fingertips should have more touch receptors. However, things like our back, which we don't really use to actually feel things, would not have as many touch receptors. And therefore, there's less touch receptors in those specific parts. How can we tell though whether one part of our body has more touch receptors than another? In order to do that, there's something called a 2-point discrimination test. Now it may seem complicated, but believe me, it's quite simple. All you need is two objects. Let's say you take two sticks, for example, and you place them close together on one part of your body, let's say your hand, right? So the idea is that when these two objects are close, then your body will feel only one stimulus. What that means is that your body will think that there's only one thing touching you. But as you slowly separate them apart, you'll start to see two different things. And obviously, the more separation is required for us to feel those two separate things, the less sensitive that part of our body is in detecting touch. Our back, for example, which is less sensitive, would require a huge amount of separation, while our fingertips would be able to detect those two different things even when they're really, really close together. And as a result, scientists do use that tool, but many scientists do feel that that is not the best tool to use, which is why they are using different things now. Anyway, like the other senses, the receptors involved in touch transmit their signals to the brain by way of neuron pathways. Let's take a look at that. Like the other senses, the receptors involved in touch transmit their signals to the brain by way of neuron pathways. The signal is super fast, as I am sure you can tell. It takes less than a millisecond for you to realize that you have kicked a soccer ball or that you have bumped into a person. The touch signal reaches the thalamus of the brain, right here, right after you're touched by something. So let's say this insect lands onto your finger. There will be a neuron that detects that and sends that onto another neuron, which is called the interneuron, that transmits the signal all the way to your brain in the thalamus. Now the thalamus is actually the relay station, which means that it takes a signal and transports it somewhere else to the brain. So then neurons connected to the thalamus will transport the signal to the parietal lobe, which, if you remember, is the station responsible for sensation. And what that means is that the parietal lobe over here has a part called the somatosensory cortex located right here, right behind the frontal lobe. And the somatosensory cortex is actually responsible for detecting our touch and processing our touch as well. The somatosensory cortex is broken into different parts that are responsible for detecting touch from different parts of our body. And that can be represented by the homunculus. The homunculus is actually the part of the somatosensory cortex. So let's say this is our brain that we're looking at from the front. And this is a cross section of that right at the parietal lobe. This part of the brain, if we break it into a smaller section, right, then we could see that different parts on the outer covering of that parietal lobe are responsible for detecting touch from different parts of our body. Remember earlier how we said that parts like our fingers as well as our lips and our nose and basically parts on our face are very sensitive towards touch signals? Well, clearly you can see by the homunculus that those are the parts that are most representative because it takes a larger amount of the brain in order to detect their touch signals. Therefore, there's more processing required for these parts, and as a result, there's more area in the parietal lobe dedicated towards them. Meanwhile, other parts like the trunk, the hip, the leg, they are still present, but not as significantly. And look, the back is not even represented on the diagram, indicating that it is extremely small, because the back has very few touch receptors. So, how is pain related to touch? After all, they should be somewhat correlated, right? Touch is very interesting, but pain is actually something different completely. These things right here are called nociceptors, and nociceptors are present everywhere in our body. They tell us that there's something wrong. So let's say we have a bottle of chili sauce and we pour it onto our fingertip. The nociceptors, and these nociceptors, beware, they don't have a cell body or anything. They're called nerve-free endings, which are essentially just dendrites that are connected to the axon. But anyway, they receive the pain signal and they transport that along the pathway, and that goes to wherever it has to, like our brain, for example. And this tells us that there's something bad that is touching us that is not good for us. The molecules within this spicy sauce that may be painful attach onto the nociceptor and signal to the brain that, look, there is something wrong that's being poured onto you. That's why if you rub wasabi on your friend's face, he or she will probably scream and run in pain. And that's why spicy is not a flavor. Spice is actually pain. And if you actually put something spicy on your tongue, all it does is trigger the nociceptors that signal to your brain that you're eating something spicy. So that is what I have to tell you about touch. Of course, there is a lot of research being done. Scientists are trying to find new drugs that can help us avoid the feeling of pain itself in certain situations. Where would that be required? Well, let's say, God forbid, you're getting a surgery. You would need something called anesthesia in order to resist feeling pain or even go to sleep. Sometimes, for smaller procedures, what doctors do is apply local anesthesia. So let's say the procedure has to be done on your arm, but we don't want to put you to sleep because that takes too much risk as well as too much effort. So what they do is apply local anesthesia. Dentists apply local anesthesia when they work on your teeth because they don't want you to fall asleep either. And those type of compounds scientists are trying to find out specifically that can help us reduce the amount of pain we feel when we are working on those body parts. However, ultimately, although we may think that pain is bad, really it isn't. It was there for a reason, and that reason is that we want to avoid any danger. When we are feeling pain, that means there's something wrong. And if there is something wrong, we either stop doing the thing that is wrong, or we have to find a way to avoid the thing that's causing us the pain. Thank you for watching this video. Please visit thebrainbunch.com to support my organization, The Brain Bunch, by donating or volunteering or perhaps doing both. Your support will help people, especially children, learn about the brain and regions, including those that are underrepresented in STEM. We've gone to over 20 libraries and schools so far, and we are continuing to go to even more. See you next time when we will talk about smell.